Hello, my name is Ruben Sansegundo and I'm going to present the ASenses framework for multi-sensorial perception. The presentation will have this index. First I will talk a little bit about the context, the main question I want to answer, some keywords, the framework and the main challenge, and some examples. Well, about the context, we have to say that currently the main research on perception is focused on how to simulate every sense with automatic system. In neuroscience, new research has provided the idea that the brain can change depending on the use of this brain. So we can define the brain plasticity or brain flexibility. So we can adapt the brain to do new tasks, and this adaptation can be done with enough training time. And the third aspect is the increment in multimodal interactive application fostered by video games company, where the main effort is focused on how to process and combine multimodal information from the user, but not so much effort has been done on how can we provide this information to the user, how the user perceives this information, or how can we increase the perception capability of the user. So the main question is, it is possible to perceive some information traditionally perceived through one sense through an alternative sense? My answer is yes, but probably it's necessary to invest some research effort on how to define a framework in order to organize this research. But I think the force is very active because there are a big amount of application. So if we talk about the signs, we have to talk about a hearing, a sense, touch, taste, smell, and if we analyze a little bit about the dimension we can deal with in the different sense, we can say that a hearing we have 1 + 1 dimension. It's true that we have 2 ears and we can estimate some localization problem, but these two signals are very correlated, so we should say that we have 1 + 1 dimension. In ASenses we have 3 dimension, and in touch most of the time we have 2 dimension, but it's true that sometimes we have 3 dimension. And for a smell and a taste we have a finite number of possibilities. About the keywords, why the A? A comes from alternative sense. When one sense is overstimulated, we can look for an alternative sense in order to provide some information. For example, someone is listening music, some acoustic warning can be provided visually. Augmented sense, because we can incorporate additional information, for example in the object we are looking at. Artificial, because we can replace a damaged sense with an artificial sense. The person can perceive some acoustic information through an alternative sense, for example touch, smell, taste. And advanced sense, because we can increase the human capabilities. We can provide human with an advanced sense, so we can increase the resolution, we can increase the range, we can increase the amount of information we can perceive. So in summary, we have augmented, artificial, advanced, alternative sense applied to hearing, signs, touch, taste, and smell. If we talk a little bit about the framework, generally if we want to translate the information coming from one sense in the information to stimulate another sense, we have to first make signal capturing and processing, information extraction, and then the new information coding, representation, and finally we have to combine this new information with the normal perception through this alternative sense. What about the main challenge? But Well, in the first model we have to improve the sensor devices for some sense, like the smell. We have to improve the processing algorithm, and we have to increase the information modeling. We should improve the algorithm to select the most important information depending on the context. We have to define how can we represent this information based on the brain plasticity, how the new information must be represented to be perceived through the alternative sense. And finally, we have to answer two main questions: how the new information must be combined with the normal perception through the alternative sense, and when or where the new information must be presented in order to avoid bothering the normal perception. This challenge must include research from different areas: engineering, neuroscience, and human modeling. Let's see a couple of examples: a hearing and ASenses.